problems. We are going to talk about two forms of log that we see a lot. So anytime you have a base of 10, that's referred to as the common logarithm. And that, anytime you don't have a base written, it's assumed to be 10. So if you just see y equals log of x, that means 10 to the y power equals x. So from now on, anytime you have no base, we're assuming it's 10. That is our common logarithm. So let's look at a situation. I'm going to give you lots of formulas in this. These are types of problems where if I were going to put this on the quiz or the test, I would give you this whole blurb again. I'm not just going to expect you to know how to calculate pH off the top of your head from now on. But I expect that if I gave you a problem with a logarithm in it, you could work from there and get an answer. So in chemistry, the pH of a solution is defined by this equation. Did you know pH was a logarithm? H3O plus is the hydronium ion concentration in moles per liter. pH is a measure of the acidity or alkalinity. You guys know if pH is greater than 7, it's an alkaline or a base. Less than 7, it's an acid. In general, we're going to round pH to the nearest 10. So let's look at this problem. I want the pH of a solution with a hydronium ion concentration of 2.5 times 10 to the negative 4. It looks ugly, but all you're going to do is use the equation I gave you. pH is the opposite of the log. H3O plus is 2.5 times 10 to the negative 4. On your calculators, we have a button for log base 10. It's fourth one up from the bottom. It just says LOG, that's log base 10. So all you have to do is type negative log button and then 2.5 times 10 to the negative 4. We round that to the nearest 10. We get a pH of 3.6. Is that one okay?
No, I have no idea.
You have no idea what?
I don't know what it is.
Oh, okay. So you're going to do a negative, your log button. 2.5 times 10.
I swear I don't know if that's exactly what it is.
Alright, so is this one an acid or a base? Acid, okay. B, find the hydronium ion concentration of a solution with a pH of 7.1. So this time I'm plugging a 7.1 into my pH. And we're going to solve for this H3O plus from the formula. Okay, we need to get the log by itself. How do you get rid of the negative? Divide by negative 1. Okay, now all we have to do is change this to exponential form. There's no base written, so my base is 10 to the negative 7.1 would equal my H3O plus. If you type that in your calculator, it's pretty ugly. You get like 7.943, and at the end it has e to the -8, that means times 10 to the -8. I would accept if you just want to leave your answer as 10 to the -7.1, that's okay with me. If you do type it in and write the other, that's fine, but it's not necessary. So either answer there would work. Questions there? So next example, still talking about pH. Wetlands are classified as bogs, fens, marshes, and swamps based on their pH values. If the pH is between 6.0 and 7.5, it's a rich fen. If it's between 4.0 and 6.0, it's a poor fen. And if the pH is 3.0 or less, it's a bog. Suppose the hydronium ion concentration is 6.3 times 10 to the -5. How would we classify it? So what do I need to do? Plug it into your formula. pH is the opposite of the log of H3O plus, which we are given. So you are just putting that in your calculator. Okay, so 4.2 for your pH. So then, how do we classify it? Poor fen. Alright. So far, so good? Let's look at another scenario. The loudness of sounds is measured in decibels. To measure with this unit, you first assign an intensity I sub 0 to a very faint sound called the threshold sound. If a particular sound has intensity I, then the decibel rating of this louder sound is given by this formula. Find the decibel rating of a sound with intensity 10,000 I sub 0. What variable am I going to plug that in for? The 10,000 I sub 0. I sub 0 is like a baseline that we're comparing it to. We want the decibel. This is the intensity of the sound. Intensity is I. So we are just going to go 10 log my I so I just plugged in for my I in my formula. What do you notice right there? The I sub 0's cancel. So our decibel rating is 10 times the log of 10,000. What do you get? Our decibel rating is 40. It's 40 decibels. So really all we're doing on these problems is being able to plug things into a formula given to us. So you just need to find your formula and make sure you're plugging your variables in the appropriate spot. Alright, ready for another one? We are going to start talking about the natural logarithm as well. A natural log is base E. That one, typically instead of writing log base E, they use ln to represent natural log. Log base 10 and the natural log are the two on your calculator. So you have a log button, and then right below that there is the LN for the natural log. So those are the two that you're allowed to use your calculator for. So let's look at one. Geologists sometimes measure the age of rocks by using atomic clocks. By measuring the atoms of potassium-40 and argon-40 in a rock, the HT of the specimen in years is found with this lovely formula. Okay, A and K are the numbers of atoms of argon-40 and potassium-40 respectively. Part A, how old is the rock, so we're looking for T, in which A equals 0 and K is greater than 0. So I didn't actually give you a number to plug in for your K, but I know that I'm going to plug in a 0 for my A. What happens when you do 0 divided by K? That's going to be 0. So when you put this in, this whole thing turns into 0. 8.33 times 0 is 0. So it simplifies to this point. So if we plug this in, I want everybody to do it, make sure you can get that answer. See what you get.
0.
0, what does that mean?
It's a new rock.
It's a new rock, newly formed. Alright, part B. The ratio of A over K for a sample of granite from New Hampshire is 0.212. How old is the sample? So again, we're just going to our equation. And I'm going to replace A over K with 0.212. Did I plug this in right? Is that what you guys got? One other thing we need to mention for today. Carbon dioxide in the atmosphere traps heat from the sun. The additional solar radiation trapped by carbon dioxide is called radiative forcing R and is modeled by this equation, where C sub 0 is the pre-industrial amount of carbon dioxide, C is the current carbon dioxide and K is a constant. Part A. Let C equal 2 times C sub 0. So if I plug that in, C is going to be replaced as 2C sub 0. When you do that, these C's cancel. And you just get K times the natural log of 2. The question is this a linear or a logarithmic function at this point? You have a log in it, but natural log of 2 just represents a number, right? So if you have R equals K times the number, is that linear or quadratic? Linear. Okay. Alright, so B, the average global temperature increase, T of R, is given by 1.03 R. Write T as a function of K. So it's basically just saying replace R. So what is R? A natural log of C over C sub 0. That's it.
Would you put equals?
This is our formula for T. So we had T is 1.03 R. We just substituted R for what it was equal to. That's all I've asked you to do there. You're done. Questions? The last piece I want to talk about is change of base formula. So on your calculator, you have a button for log and you have a button for natural log. Now you guys are no fools, and I know you play around with calculators. There are ways to insert logs with other bases on these calculators. However, not all calculators have that option. And there could come a time where we have expressions that we're not just plugging in the calculator, so we need to know how to go back and forth between different bases. So we need what's called the change of base formula. So you can take any logarithm and rewrite it in any base you want by doing the log of the current argument divided by the log of the current base. Typically when we do this, we are going to be changing it so we can use our calculator easily. So we're going to be changing to either base 10 or the natural log. So the most common forms would just be using regular log or ln, log of the argument over log of the base. It won't matter which one you use, you'll get the same answer there. I don't think I've printed these, but I just want to do maybe 2 quick examples and make sure we know how to use this, and then I'm done. So let's say I asked you to approximate log base 5 of 7 to 4 decimal places. So on a tester quiz, I would require that you show me the step where you change the base, so I know you're not just going into the menu in your calculator and finding a way to plug it in. So you would have to show me work here. We can change it to common log or natural log. Which way do you want to go? Natural log, so we can do ln. So you do log of the argument, so that's the big number, over log of the base. Put this in your calculator, do it all at once so you don't have rounding error. So log 7 over log 5, you have to make sure and close those parentheses when you put them in. And if you round to 4 decimal places, you should get 1.20. 091. Did everybody get that? B, we would do the same thing. If you wanted, you could go to common log, it doesn't matter. So it'd be log of which one? The 110 over the log of 2. You get negative 3.3219. Any questions or problems? So that's the end of today. You might want to keep this handout handy when you're working on the homework because it'll